Hello and welcome everyone to this talk of semi-technologies about Weaviate and GraphQL, and specifically how we shaped our GraphQL API to meet our user needs in this data science realm. I'm Laura. I am a community solution engineer at Semi-Technologies, and I will guide you through this talk today. So, as I mentioned, I'm going to focus on how to design a GraphQL API from user needs in the data science spectrum. But first, I will start with introducing you to Weaviate. Weaviate is an open source vector search engine that we built to scale and leverage machine learning models. I will talk a little bit about the background so that you know why we chose GraphQL for this. And then I will dive into how our API architecture looks like and why we chose GraphQL for Weaviate. And of course, I won't forget any demos to show you finally. So first, Weaviate. What is it? Weaviate, as I said, is a vector search engine, which is different from a traditional database. So let's say we have some data of wines. We like to store wines, and our data can look like this. So we have a title of a wine. We have a Covey Run 2005 Chardonnay. And with a traditional search engine and traditional database, you or your customers might be looking for wine that fits with a fish or seafood dinner, and enter this in a search query, but might not find any fitting wines there. That is because these wines are not stored with the concept of seafood. So the database doesn't know which wine fits with seafood or not. But with a vector search engine or a semantic search engine like Weaviate, if you make the same search query, you might see results because the meaning of the wine and the descriptions are stored along with the data itself. And how does this actually look? How does this work? So we don't have, like Weaviate doesn't have a traditional database structure in the background, but data is stored in high dimensional vectors. So as you can see on the right, data is stored with its meaning to a location in a vector space. And you can think about this as a supermarket, for example. So apples are next to bananas because they're both fruit, but they are further away from beer and wine, and also not at the same place as fish and chicken because they are another type of food. Now, this is also how we store data in Weaviate. And this is done with a pre-trained machine learning module, in this case, a natural language processing module. And this can be used for automatic data classification and the semantic and smart search that I showed you before. So in conclusion, Weaviate really understands your data. To recap, so we have a pre-trained machine learning module. If you add your own data, it will be placed according to its meaning, also in the same space. If you do a search query, you will also have this query in your data, and you will get back the data that you're looking for. So different kind of wines that fits with seafood, for example. So how does this then look like? Weaviate also needs an API like every other database system. So first we gather some user needs based on various use cases to see how we should design our API, because Weaviate is not a traditional database, but people can do a lot more with a database like Weaviate. So first of all, the normal CRUD operations could be solved by simply RESTful APIs. But then with Weaviate, we can do more. So people want to do data search and explorative data search. They want to browse through all their big data, and they want to do analysis on metadata. And for this, we chose to do GraphQL because these kind of operations are not really efficient with RESTful APIs. And with GraphQL, we can ensure a high user experience in these cases. And then I've listed 2 more user needs over here, but of course there are way more. We have the very important point that API requests should happen near real time on very large data sets as well, because we are using Weaviate in production cases and not only in machine learning research cases, for example. So timing is very, very important. And then secondly, we don't want to bore developers with all difficult API integrations, so it should be really easy to integrate in their existing or new applications. And for this, GraphQL is also really helpful. And for the last point, we also made a lot of client libraries in which both the RESTful API endpoints and the GraphQL endpoints are available to even increase the user experience more. So again, why exactly GraphQL? First of all, we also have graph relations in our database. So next to the fact that we represent data as vectors, we can also make cross-references between data points. And with GraphQL, it's of course very efficient to also retrieve this kind of graph relations from the database. Secondly, performance. So there's no overfetching or underfetching, and we're reducing the number of requests by using GraphQL, because with RESTful API endpoints, you might need to do a lot of requests, and this will also, of course, cost a lot of time in production. And then finally, where it all comes together is the user experience. So we want to reduce complexity for the users. And as you know, GraphQL is, of course, also less error prone because it has a fixed schema. And we have a custom design for each use case. The GraphQL is adapted, which makes it really natural for users. So how did we design it? I listed here 3 main principles that we used in designing the structure of the schema in our GraphQL API. First of all is using natural language, because we also want to have it understandable for non-developers. Secondly, we have a class property structure in Weaviate data, so this should be also represented by GraphQL. And then thirdly, we want to add filters to queries that depend on the machine learning model that the user is using, for example. So depending on the database setup, the GraphQL API is formed, kind of. So how does this look? For the 3 main functions that we have, as I said before, so search, explorative search, and data analysis, we have 3 functions: get, explore, and aggregate. And these are kind of natural language, as I said before. And then, this is at the highest hierarchy of the GraphQL functions. And then it goes to the classes and properties that are defined by the user themselves in their data schema. So the design is really simple. And then we have a lot of filters on which the users can filter and search through their data. So let's look now how this looks in real life. So here I have a data set of the wines that I also used as an example earlier. If we want to see what kind of wines are in there, I can do a simple get function, ask for the wines, and let's go for just the title for now. And we see on the right that we just receive the titles of all the wines. So nothing more, nothing less. This is super powerful about GraphQL, of course. And we have more, so we can also ask for the reviews or the descriptions of the wines. and a piece of text will appear for each returned result. I can have the cross-reference or the graph relations, as I said before. So we have a link between certain countries that wines are produced in and the wines itself. And I can add this to the query. So now I want the name of the country also next to the title and the review of each wine. And I see the first one doesn't have a country in the data set, but the second one is from the US, etc. So let's remove this for readability. Then I can make simple filters. So a really simple one is just limiting the amount of results. If I set a limit to 1, I only get 1 result. So that's really straightforward, but yeah, really simple. Then we can do traditional database search. So no like smart search or smart explorations, but just as you have a SQL where filter, we can also have it here. For example, if we want to see wines that are scored really high by reviewers, we can say that the points should be, for example, greater than 90 on a scale of 0 to 100. We can do it like this. So we add a filter here, which is called the where filter, where the points are greater than 90. And let's also get the points here. Oops. Okay, so now we only have wines that are above 90, have a score of higher than 90. And you can see the natural language appearing here. So we want to get wines, only 10, where the points are greater than 90, and we want to have these properties back. Okay, so now let's look at something else. The smart search, that's the thing that Weaviate is actually good in. And we call this near text. So we want to search for wines. What did I say before? Wines that fit with the seafood, that fit with seafood dinners. So let's add some natural text. Wine with seafood. And we get back the first result is a wine that pairs with richer seafood, second one with seafood, and so on. And we can specify this more because we can, the amount of filters that a user sets is of course up to the user, and we have quite some filters available. So we can, for example, move through the space if we want to have, for example, a wine with seafood that is sweet. So now I add another filter. I'm moving literally through the dimensional space. And if I run this query, I get different results because I changed the search query a bit. So this is basically how we search with natural language using GraphQL in a vector database. And yeah, we can have really long sentences here because this is just a string, and it will be vectorized with Weaviate in the backend. All right. Let's move on. So as I mentioned, we don't only offer GraphQL APIs, but we also offer a set of client libraries where we implemented our whole GraphQL design actually in the clients, so that it is also easy to use GraphQL in, for example, Python or JavaScript or Go. And so query similar as I showed you just before in the demo. is really easy in Python. We add the filter here also as an object, but then, we have a query.get function in Python with the same variables, which just executes the query, and you will get this back in your Python code. So this is an example. This is an example of how you can, not only stop developing at GraphQL, but also go on and use GraphQL in client libraries. So that's most of the things that I want to say. And of course, you can try this out. So we have, Weaviate is open source. So this whole vector native database is open source and free to use to all of you. And also the interface that I just showed with some demo data sets are available if you go to console.semi.technology or to our documentation on semi-technology/developers. You can read on how to get started and play around with our GraphQL design. Thank you. That's it. And I'll be present here to answer any questions of you. Thanks.
So, Laura, that is incredibly compelling to me. I personally spent time in the search space. And so to see the collision of sort of two sorts of technologies that I love immensely is exciting. One of the things you said has really sort of stuck in the back of my brain, and I can't quite get it out. And you described API design from user needs. I think we often design APIs based on technology implementation or based on choice, but not based on user need. Would you share a little bit with us about what led you to that journey, how you sort of approached that interaction model?
Yeah, sure. So thanks for the question, Tyler. So usually, as you say, we have a great piece of technology and you want to serve great endpoints to your users so they can use every great feature you have, right? But there are, obviously multiple ways to do it. And especially with GraphQL, where you can design your own schema, your own, design how people can query it actually. It's actually great to listen to your users. So of course we have a piece of technology where we maybe even start thinking from by default as a company employee, I would say. You also have the users. By telling them and having conversations in more human language rather than technology language, you can really identify, okay, what are they really looking for? What are the features they need and how do they want to retrieve it? And in an iterative approach with proposing concepts and proposing designs to them, we come to a final solution.
I think we, as an industry, would do well to take that to heart. As you went through this journey, was there anything in particular that sort of surprised you along the way? Were there any decisions that were made that maybe weren't what you were thinking about to begin with?
I can't think of big decisions, but it's surprising. I learned a couple of things. First of all, is that if you just ask people, they won't tell you directly what they want because they don't need it, what they want. They only see what they want if they actually see it. So it's really important to also come up with your own designs, but not influencing users too much, right? And that's really hard. It's really hard to do, and something I learned. And secondly is that we, as technology or software designers of Weaviate, also use Weaviate ourselves a lot for use cases. And so we are our users ourselves as well, which is great because you experience what could be improved, etc. But we're a different kind of users than the real users. We have a lot, great set of pre-knowledge, which you sometimes forget that new people don't have. So you have to take that in mind as well.
Yeah, absolutely. I think Yeah, it's exciting for me to see this collision of GraphQL and the sort of ML, NLP, vector search space. Like it's exciting because it's not the standard thing you run across when you read about GraphQL. At the end there, you mentioned, hey, try it yourself. Would you mind just sharing what those links are, and maybe an example of some use cases you've seen recently that are particularly exciting to you?
Yeah, of course. So you can always try, as I said in the end, so go to console.semi.technology, or have a direct link with a demo set behind it in our documentation. You can find at semi.technology. And so now we like the most use cases are with free text and unstructured data in textual format. But what's really exciting is that we are experimenting with like other forms of data than text as well. So think of images, for example. To factorize them and put them in a vector space database and search semantically with the images. We're also going to the medical domain. So fine-tuning machine learning models to medical domains, for example. Lots of exciting things to happen.
It's super cool. I'm looking forward to playing it with myself. Laura, thank you so much for sharing this information, for sharing your journey, and for joining us in what is a fairly early morning.
Yes, thank you a lot, Tyler.